right, this video is on fingerprints. So fingerprints can be recorded with ink. They actually can be recorded with lasers also, and we can find their primary identification number. When it comes to lifting prints, we can do this with powder or chemicals. And then there are a whole bunch of other types of prints as well besides fingerprints. So dactyloscopy is the study of fingerprints. So a few people historically, Herschel, he used prints to identify Indians in India, have them identify themselves on contracts, and to make sure the right people went to jail. Faulds claimed that fingerprints didn't change over time, so you always have the same one and we can classify them. Bertillon, related to fingerprints, looked at body measurements for identification, which is called anthropometry. Galton classified them as loops, swirls, and arches. Edward Henry worked with Galton, and he came up with a numerical classification system. And Budicic did similar work to Galton's and Henry's work, and they used his classification system in Spanish-speaking countries. So fundamentally, it's an individual, right? As far as we know, no one has the same fingerprints. They stay the same your whole life, and they have ridge patterns, which allows us to classify them and compare them to each other. So these ridge patterns or ridge characteristics, sometimes called friction ridges, we call them minutiae. So these are these characteristics, and you can see what they look like in these drawings. And here's what they look like on a real print. So you can see a couple to point out that come up often are things like right here, you've got a double bifurcation where it forks and it forks again. A ridge ending where it just stops, that line there. It's just a bifurcation. There's two of them actually. The core is the middle where you can see the lines kind of like turn around or do something. I suppose turn around and come closer together. And a delta is something you need to be able to find. A delta, and this one is right here. You can see it's where these lines kind of come together but then don't cross. I always think it's kind of like a triangle. All right, so 3 types. An arch. An arch has friction ridges that come on one side and go out the other side. They go up in the middle. So it's kind of like a little hill like this. You see they don't have any deltas, so no deltas. They can be plain or tented. This one here is plain. Tented is just where it goes up higher. All right, next is a loop, and a loop has at least one line that comes in and out the same side, and they have one delta. That's really important. So see if you can find the delta on this. Pause for a second to do it. It's right here. You can see the lines here, here, here. All right, so one delta is a loop. Loops can be radial or ulnar loops. So looking at the lines I drew, you can see they come in and out this direction. So if you hold up your right hand and you see where that arrow is pointing on your right hand, if that was where that loop was, the arrow is pointing towards the thumb, which means this would be a radial loop. If you hold up your left hand, that arrow would be pointing towards the pinky. So on your left hand, this would be an ulnar loop. Okay, and these names come from the arm bones. The bone on the pinky side between your wrist and your elbow is the ulnar, and the bone on the other side, on your thumb side, is the radius. All right, so a whorl then has at least one complete circle. So you can see right here, and it has 2 deltas. So one here and one here. You can see where the lines, right, don't really meet but come together. And they have at least 2 deltas. So 0 deltas is an arch, 1 is a loop, 2 is a whorl. And you can see there's a whole bunch of different kinds of whorls, and we can look at more pictures of those as we keep going with this. All right, your primary classification, this Henry code, it has to do with with where whorls are on each finger. All right, so you assign the number of points for each finger that has a whorl. So let's say this person has a whorl here, 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 and here. All right, so what we do is we go put those numbers in where that finger is on the code. If you don't have a whorl there, it's a 0. So they had a whorl on their right thumb, which means this is a 16. They had a whorl on their right little finger, so that's right here, so that's +4. And then on their left ring, it was a 1. And on their left thumb, it was a 4. So on the top, it's just 4. On the bottom, it's 16 plus 4 plus 1. But then notice these. So you're adding 1 to both of those. So what you get is 4 plus 1, you get a 5. And then 16 plus 4 plus 1 plus 1 is 22. So this is the Henry code for this person. It just helps us look at a smaller group of people when trying to identify and not looking at every single print or set of prints. All right, there is no legal requirement in the US for the minimum number of points, meaning you could technically identify a match with just 1 point. However, most courts prefer obviously more, like 8 to 12. Some other countries have a set number for a standard. Latent prints are the ones that you can't see. So these are there, just not visible, due to glands in your skin that release different things. So the eccrine gland is mostly water with a whole bunch of inorganic and organic substances in it. That is the most important. So there's some of your sweat and such. The apocrine secretes pheromones and a few other organic materials. And the sebaceous is like the fatty, oily, greasy substances. So when we're developing prints, they have to interact with these. So powders are one way to do it. They're going to interact with the water and the fatty deposits. You got to have a contrasting color so that they will stand out. Iodine will react with the oils and fats. You'll get this yellow-brown reaction. Iodine is going to look like this. Okay. Ninhydrin reacts with the amino acids, and you get this purple color. So this is what a ninhydrin print looks like. Silver nitrate reacts with the chloride. You get silver chloride, which is like this really light gray color. When you put light on it, it'll actually be exposed, and you'll see it show up. And cyanoacrylate, which is superglue fumes. So if you heat up superglue, the fumes will react with the water, and then some of the other things in fingerprints, and you'll get this hard white deposit like this. These are some superglue fumed prints. All right, other prints are your ears. Your ears have a unique shape, length, and width. Your voice does as well. Your foot, right? If you actually look at the bottom of your foot or your toes, you have like fingerprints on your toes. And then shoes could be, there's definitely prints there. They're not always individualized, which we've talked about. All right, you've got your whole palm, which has unique prints to it. Footprints, like I just said, they actually use them for babies at birth for identification. And then your lips have unique patterns and lines, which comes up a lot because we leave them behind when we're taking drinks of things. So lots of glasses. All right, teeth and bite marks can also leave an imprint behind. These we need to be very careful with. They are individual, but not always the most precise, and these can change. So these should never be kind of used alone. All right, your eyes have blood vessel patterns, so these can be used, or retina scanners for security purposes sometimes. All right, so where are all these fingerprints stored? They're stored in what we call AFIS, so it stands for Automated Fingerprint Identification System, which is the computer database for storing and retrieving fingerprints. It started in the early 70s so that they could search these large files. They can compare a single print from a print found at a crime scene. They had to create this international big database because when everyone had their own, you weren't able to cross-check prints easily from one place to another. All right, and the last thing is, like I said, that anthropometry, the Bertillon system. Today they'll use this with AFIS, so lots of times they'll collect data on not just fingerprints, but like retinal iris patterns in your eyes, voice recognition, geometry of your hand, other measurements in your body, right? Because more evidence obviously gives us more confidence in what we're dealing with. So that is fingerprints, and those are our notes.